So today we're going to be learning about one-directional motion graphing. And so before you continue this video, you should probably look at the vocab that's on the wiki and learn it. You guys probably already know it. It's pretty simple. So one-directional motion graphing has to do with graphing an object relative to time. So it's position versus time, the velocity versus time, or acceleration versus time. Those are the three types of graphs that are present in this curriculum or unit. So let's get to it. So as I said before, there are three different types of graphs. The first one being position versus time graph. And a position versus time graph, it measures your position versus time. So it tells you how far you're going. In this graph, the person or the object didn't really go anywhere at all. So the position is just going to stay constant. So the velocity is going to be 0 because he's not moving at all. So this is a velocity versus time graph, and a velocity versus time graph has to do with moving in a certain amount of time, or your speed in a certain amount of time, with a given direction. So right here we have our velocity. So our velocity is constantly changing, so our position is going to be also, it's going to have a curve to it because it's going to be constantly changing. So this is an acceleration versus time graph. And this graph has to do with the change in velocity over time. So it's the biggest one, kind of. And this graph has, right here, is also changing constantly. So right here, there would be a curve. And the reason why I keep saying that is because these graphs have all have to do with each other. And so the integral of a graph is the area under the curve. So essentially you can think of it as moving up and down, because this is, and so basically if you have the area under here, that's going to be this graph. If you have the area under here, it's going to be that graph. So you basically kind of just, they relate to each other, and then derivative is at a certain point. So this is how some graphs look. And position versus time graph, if you have no movement, it'll just be a line anywhere on the graph. You can start right here, over here, over here, way up there. You can't see that. But yeah, in a constant movement graph, you'll just be moving constantly. And your velocity is going to be, it's just going to be a straight line to the right, so the velocity doesn't change. Increasing velocity means that's going to change constantly, and so it's a curve. A velocity versus time graph has no movement in it, or this graph has no movement in it because it's at 0. You can't see that, but it is there. Constant velocity, your graph will be changing constantly, so it's just going to move like that. And if you have increasing acceleration, then it's going to have a curve to it. And this graph relates to a diagonal acceleration, that one. And so an acceleration versus time graph this graph has constant acceleration. Sorry. Okay, that's better. Never mind. Okay, and this graph has no acceleration. I didn't show the other graph for some reason, but like I said, it relates to this one. It's going to be changing acceleration, so it's going to have a diagonal line. So this is the basics of graphing one-directional graphs, and I hope you guys enjoyed or learned.